All right, finally we're going. Okay, so welcome. This is Math 212. My name is Jhevon. It's okay, you can call me Jhevon. So Math 212. This is Calc 2. Well, previously Calc 2 used to be Math 202, but we added stuff. So it's Calc 2 with an introduction, we're not going to completely do it, to multivariable calculus. In other words, traditionally, it's Calc 2 with a little bit of Calc 3 thrown in it, what's traditionally Calc 3. So there used to be an age-old debate. What do you think is harder, Calc 2 or Calc 3? You know, and some people think Calc 2 is harder, some people think Calc 3 is harder. They're like, well, you know, Calc 2, there are all these formulas and all this stuff you have to do, and then Calc 3, oh, you have to do things in 3 dimensions I can't visualize. So some people like Calc 2, some people like Calc 3. City College decided to put that to rest. This class is harder, for sure. Right? The new Calc 2 is the hardest course in the calculus sequence, for sure. Not debatable anymore, okay? Because we're doing Calc 2 and some of Calc 3. So all the things that make Calc 2 difficult, we're going to do them. And all the things that make Calc 3 difficult, we're going to do those too. So yeah, if you can make it through this, the new Calc 3 is actually probably going to be pretty easy. Yeah, this is the hardest course now, so just so you know. So don't slack off. I guess. Not to scare you, but you should be a little bit afraid. Like you need to actually pay attention here. So like I said, Calc 2, usually people who are science majors, except biology, engineering, and math majors would need this class. Otherwise, I guess if you're here for fun, that's okay too. That's my email. I will be emailing you from that, so you should also be on watch if you get an email from this. That's the one I use for my students because I have trouble with my City College email every now and then, and I lose emails. So if you want to converse with me about this class, email me there. These are my office hours. I'm pretty sure that location is now going to be changed. As soon as I know actually where I am, they'll probably move me somewhere to the 8th floor, but as soon as I update the location for office hours, I'll let you guys know. This is my website. That's the general website. Your class's website, this is section RS2. The website for this particular class is that. That's going to be important, and I'll be sending you there quite often, and you should actually be well acquainted with that website. On that website, included on that website would be an electronic version of this document, where all of these things that you see underlined are actually clickable, and you can actually go to the whatever web pages are referred to here. That's the main math department website. That's the main 212 website. I'll probably send you there towards the end of the semester because they'll probably post some departmental finals there, and I'll send you there for practice. And which brings me to the next point. You guys will have a departmental final, so I'm not writing your final. I'm pretty much teaching you so that you can pass someone else's test. So, you know, not that I take it easy on you anyway, but I really can't take it easy on you, right? Because if I let you slide, then someone else is going to punish you, so we can't have that. You'll be doing a departmental final, and chances are they'll post some mock finals here, which I will send you to later. This is the course description. It'll cover a lot of things from Calc 2 as well as Calc 3. Calculator is not allowed, so you might have to use them on homework, but that's pretty much the only place you'd use them. On any quiz or test, you can't use calculators. You don't have to purchase a physical text. You will need to purchase online materials, though. You need to access the homework system online. The entire department is doing this thing now, so like I have no choice. You have to pay for homework access. Information on how to access the homework is on the class webpage. So if you go there, there's a section called homework, and it'll give you instructions. Here's how to sign up for homework. Here's how to register. Here's how to buy it. And do be careful. There are discounted purchase options for CCNY students. So if you actually try to purchase these materials from the main website, it'll actually charge you more than if you go through the special link that's on the class webpage. So be aware of that. Usual grading chart. As is also typical, 40% of your grade will depend on your final exam. The final exam is cumulative. The final exam is 2 hours and 15 minutes long. The final exam will be written by the math department, not me. Yes?
Sorry, just to be clear, the big website at the top, the class website, that's where we find...
This is the class website. So that's the website for this class specifically.
That's where we find the link to get the online
to get the homework, yes.
Okay.
So there's a special link where as a seated college student, you'll be able to get a discount. That being, I'll try to talk about that a little bit more later. All right, so finals 40% of your grade. The rest of your grade is broken down thusly. Quizzes, you'll have a quiz every week. I'll drop the 2 words quizzes, so if you miss a quiz or you just do poorly on 2 quizzes, you can drop 2 of them. Homework is 5%. Participation is 5%, so I'll be calling roll every week, and if you show up, you get 5%. If you don't, you lose the 5%. So attendance is important, and you'll actually get credit for it. In-class exams, I'm giving 2 of them. Each will be worth 20% of your grade, so for a 40% class total. Final exam is 40%. Like I said, that is cumulative. The quizzes and tests aren't cumulative. Quizzes will tend to cover what I covered the previous week, and the test, I'll tell you specifically what the test covered. Each test covers later. Make sure you write your name on this. Okay, continuing. Next page. Pretty much reading through the syllabus video, so you can't say, I didn't know. Everyone's gonna know all the rules. Okay, so make a policy. You can't make up a quiz or homework. So for the quizzes, I dropped 2 quizzes. So if you miss them, that's just gonna be dropped. For the homework, the deal I'll strike with you with the homework, I meant to write it here, but I don't think I did. It is if you get 85% or higher in the homework, I'll just automatically bump that up to 100%. So like, oh, professor, you couldn't finish the last problem on homework number 12. So can you extend it? Not gonna extend it, right? You have a 15% leeway. Right? I just want to set it and forget it. So you have a 15% leeway with homework. So you can miss a couple, don't miss too much though. You get 85% at least, I'll bump it up to 100. Like I said here, attendance is important. If you stop showing up and you don't let me know what's going on, and you accumulate 5 unexcused absences, you'll automatically fail the class with a grade that's worse than an F. GPA-wise, it will be an F, but it's written as WU. So that basically said you got an F because you stopped showing up and weren't responsible enough to tell anyone. So it's like F with a connotation of you were extra negligent. You don't want that on your transcript, okay? So if anything happens and, the disaster happens in your life, just shoot me an email and let me know, hey, Jhevon, stuff is crazy, I can't show up anymore, blah, blah, blah. I'll tell you what you need to do. But don't just stop showing up and not say anything. Don't do that. If you're late or absent, you need to email me with the reason and provide proof where necessary. Paragraph here about work ethic, like I say, don't slack off. This is the hardest course in the calculus sequence. It's probably going to be one of the hardest courses you take in your life. I don't know. Depends. So, moving on. Homework, like I said, it's going to be online. It's going to cost roughly $80 and $115 if you get the paper textbook with it. I would recommend getting the paper textbook as well. So it'll cost you at most $115 through the special link. It actually costs more if you go directly to the website. Quizzes, as I said, given in the class, the first class of every week, so pretty much every Tuesday I'm going to give you a quiz. And it will tend to cover the week before, all the stuff that I taught you the previous week. You come back on Tuesday, I'll quiz you on what you did the previous week. It's mostly going to be short answer, fill in the blank type questions, things that I can grade real quickly and just get back to you, and you can see how you're doing. Tests, these are long forms. It's not short answer, fill in the blank. You have to show all your work, and I'm going to grade it, give you partial credit. Final exam is cumulative. The other assessments are not, and that's given at the end of the semester. And as for the actual date, I don't know yet because it hasn't been decided, but I'll tell you how you're going to find out later on. Moving on. Prerequisites. I expect you to remember all the math you've ever done. You need to know pre-calc, you need to know calc 1, you need to know them very well. Okay, like extremely well. I do, like how I'm recording this, I also recorded my lectures for pre-calc and calc 1. So I taught pre-calc in spring 2019, taught Calc 1 in fall 2019. Now I'm here teaching Calc 2 in spring 2020. That's a link to my pre-Calc playlist. That's a link to my Calc 1 playlist. If you're lost on anything, or you just want to know, does Jhevon really expect me to know that? Go here. Like, I always tell my students exactly what I expect them to know. So if you ever want to know how I teach something, or what I expect you to know, or what I expect you, the knowledge I expect you to have in your head, you can go here. On the class website, I also posted some links to Khan Academy and some other stuff. But we'll talk about how to get help later. Moving on to the next section, blasphemies. Okay, so these are important. Let me make sure I write them down so everyone knows what I'm talking about. No one can say, I didn't know. Okay. Blasphemies. So, inflammatory language I know, but that's on purpose. So blasphemy is a really, really bad offense for which there's a really, really bad punishment. And the blasphemies in this class are the following. So these are the do nots. These are things that you will not do under any circumstance, even if someone's holding a gun to your head and threatening your family. It doesn't matter. You do not do these under any circumstance. 1, do not cancel across sums. What do I mean by cancel across sums? Okay, let's say you're working on a problem, get to a point where it's 2x plus 1 all over 2. You cancel the 2's. You do that, I'm going to be very upset with you. That is wrong. You cannot cancel the 2's. This is called canceling across sums because of the plus sign here. It also works with the minus sign. You can only cancel across multiplication or division. So these are in parentheses and that's a multiplication. You're allowed to cancel the 2's. Okay? So, you do something like this, I'm going to be very upset. I'm going to stop reading whatever else you've written. I don't care if you prove it Fermat's last theorem as a second part of your answer. I'm going to give you 0 for that answer. You made this mistake, I give you 0. Okay? Another thing, do not. Do not distribute powers across sums. Hey, what is that? Well, that's like if you see x plus 2 all squared and you tell me that's x squared plus 4. You do that, I give you 0. I kill you. Okay? You cannot do that. You cannot just take the 2 and attach it to this and attach it to that. Powers don't work this way. Similarly, this one always catches people with a radical. Suddenly, even people who won't make that mistake would often make this mistake. They see a radical and they think, oh, you can just do that. You cannot do that. That is incorrect. In fact, to expand that, you'd actually need an infinite number of terms. Like it's not like in this one, you're missing one thing. It's really bad. Like, if you actually were to actually expand out x plus 2 all squared, it's x squared plus, should have asked you guys what that was. That's it. So you're missing a whole middle term, 4x. You write this, you are literally missing an infinite number of terms, right? Technically it's not in our syllabus, but I might mention very quickly how you can expand this when we get to series, because you can use series to expand the radical. But the point is, it's not going to be just 2 things. It's going to be a list of an infinite number of things. You missed most of the answer by doing this, right? So you can't do that. Why? Because radicals are powers, right? That's just another way of writing that. You can't just take the half power and put it here and put it there. Illegal, right? You do that, I kill you. Okay? Do not distribute powers across sums. Do not divide by 0. Like people still do it in 2020. You would think by now they would know better. Do not divide by 0. Now, yes, you've all been through Calc 1 and you've all taken limits where it's kind of like dividing by 0. No, it's nothing like dividing by 0. Limit, if you're looking at something like this, your x is never actually 0. It just gets very close to 0. But even when your denominator is getting close to 0, it's not even actually 0. A lot of craziness can happen. If you look at that versus that versus that versus this. Like the denominator of all of those are going to 0. What happens when you almost divide by 0? It's infinity. Well, is it? What is this one? Does not exist. What is this one? Infinity would be the answer. What is this one? What is this one? Right? When your denominator is going to 0, anything can happen. You can literally get any answer. Do not think of division by 0 as having some sort of meaning. Division by 0 is gibberish. It means nothing. So if you write something, oh, and you get to 1 over 0, oh, that's infinity. I give you 0. I stop reading. Right? That's meaningless. You cannot have 0 in a denominator. Okay? Don't divide by 0. Another thing you should never do. Use do not think you're differentiating a product of things that you can just differentiate this part and differentiate that part, right? So you'll see people like they're trying to differentiate x times sine of x, and they write, oh, that's 1 times cosine of x. No, it's not. That's not true. That's not correct. There's a whole thing called a product rule, that when you see the derivative of a product of functions, there's a whole, so that, let me make sure I mark that out so someone's like copying down, not paying attention, right? So, what is that, by the way, f times g, the derivative?
The first one and the second one plus the derivative of the second one to the first one.
Right, that's it. There's a whole product rule. By the way, while I'm here, whenever I ask you to tell me a rule or a formula, I expect you to tell me the entire formula. So a lot of times I would ask students, what is the product rule? And they'll say f prime g plus f times g. That's not the product rule. The product rule is an equation. It has a left side and it has a right side, right? Don't think of the right side as the product rule. The entire equation is the product rule, right? The moment you start dropping off little bits and pieces off your notation, you will start to suffer, and you'll wonder why you're suffering. I'm working so hard. One of the reasons is you're very sloppy with notation. So be careful. Whenever you need to memorize a rule or a formula, memorize the entire rule, memorize the entire formula. So you cannot just integrate a product by integrating each pieces. You can't differentiate. What's this?
F prime g minus f prime over g squared.
Right. It's not like just differentiate that and differentiate that. That's incorrect. Right? The whole quotient rule that you would have to go through. So don't do anything like that. Also, don't think that the same thing works with integrals. Integrals, as you will learn, are much harder than derivatives. If something doesn't work with a simple thing like a derivative, it's definitely not going to work with an integral. So you see the integral of f times g, it's not the integral of each piece and sticking it together. Right? So if you have the integral of x times sine of x dx, it's not, you can't just integrate this, x squared over 2, you should know that that's the integral of that. Integrate the sine of x. What's the integral of sine of x? Negative cosine, guys, it's way too long for that. Way too long. Okay, negative cosine of x plus c. See, that is incorrect. In fact, most Calc 1 students don't actually know how to integrate that. We're going to learn how to integrate that Thursday. Thursday we're going to learn how to integrate that. How would you integrate this? U substitution. U equals what? Right, and you continue du and blah blah blah, find all that stuff. Okay, but you can't distribute an integral across a product. You can't distribute a derivative across a product. You can't distribute an integral across a division. You can't distribute a derivative across a division. I expect you to know that. So don't do this. Don't do that. You see this? You can't just integrate this part and integrate that part and stick them together. That's wrong. For this, you would need a substitution. For that, you'll need a whole other method that we're going to talk about on Thursday, called integration by parts. Don't make mistakes like that. If I see that, I just give you 0 and I move on with my What else do I want to tell you never to do? 5. What is the integral of 1 over x dx? No. ln of absolute value of x plus c. Right? Now, here's the mistake. A lot of times students will see 1 over some function, and they think that it's ln of that function. That is not true. That is incorrect. In general, that's incorrect. Only 1 over a linear function is going to give you that ln, or you should be able to make a substitution to get to a linear function. But in general, if you have 1 over f of x, it's not ln, right? So if I had 1 over x squared, how would you integrate that?
Integrate x to the negative 2.
You raise x to the negative 2. Again, you're taking too long. Then what?
Add 1 to the power.
Which is
X.
x to the
Negative 1.
and? So that's how you do. No ln shows up, right? You just have 1 over something, doesn't automatically mean an ln shows up. Don't just automatically just throw in ln's anywhere just because you see 1 over something you want to integrate it. So don't do that. The 6th item, which is, it's weird, it's a do, not a do not. Use parentheses appropriately. Appropriately. In fact, this is just one thing in a much larger thing. Use proper notation in general. Now sometimes you're going to want to get lazy. You're going to want to not have to write something out even though you know you should write it out. You know those times, I know the parentheses should be there, but I'm not going to write it. More often than not, you're going to end up making a mistake because you're going to have this huge test. You're going to be under pressure. You're going to try to be rushing to get through stuff. If you have imaginary parentheses on your paper, you're going to forget them at some point. You don't want to do that. And just in general, being sloppy with your notation causes all sorts of issues. So be sure to do that. So first 5 things. You do any one of those first 5 things, I give you 0. And while I won't automatically give you 0 for not doing this, if you make a mistake because you did this, I'll punish you very heavily for it. I may or may not give you 0, depending on the situation. Like if anyone's like trying to find a derivative and they, like we want to find, so f prime of x by the definition. What is the definition of f prime of x?
The limit x equals to 0 of f of x plus h minus f of x.
Okay, so now if I tell you f of x equals x squared, and I ask you to find the derivative by the definition. Okay, so here's an example of how you can get 0. If you just think of this as, oh, that's just x squared plus h minus x squared all over h. You write that, I give you 0, right? But the correct thing is x plus h squared minus x squared all over h. Now, technically what I'm talking about is that you should technically want parentheses here. Now, yes, it's overkill to put parentheses here, but it's important because if you had several terms, right, this negative sign would have to distribute to all the terms, right? So you should know, like, after a minus sign, I open parentheses. Don't do it in your mind. Actually write it down on paper. It's going to be worth the effort, trust me. Yeah, that's the blasphemy section. Right, don't forget your plus C. I forgot to say, don't forget the plus C. Like everyone forgets plus C. Don't forget the plus C on the integral. Like I won't necessarily give you 0 for forgetting the plus C on a definite integral, but I'll definitely subtract at least 1 point if you forget a plus C on an indefinite integral. So don't do that. All right, contact. When necessary, I will contact you via email. You'll either get emails from my email listed on the first page, or from a website called Jupyter Grades, which is where I keep your grades, and it's In fact, while we're here, let me actually do that. So I'm going to send you an email right now. That's going to help you access the homework. The grades. So all your class grades, you are going to be able to log into this website to see your current grades. Check it after class, make sure you get it. Hi. Click on the above link to view your grades. It'll ask you to set up a password. Best joke. Okay. Alright, so I just sent you an email. And most of you, if you're already here, you all now have A pluses because there's one grade so far. Your attendance projected at the beginning of class. The people who are late, they're already at Fs. It's like day one. So, yeah. Now, yeah. So check that. Make sure you get that email. Sometimes I'll send you mass emails directly from this website. So make sure that it's not going to your spam folder. So either emails from me or Jupiter Grades. Make sure you're getting them and make sure you read them when you get them because that's going to be important. Okay, so help. Because everyone needs help sometimes. Don't feel ashamed if you ever need help. There are many, many, many options to get help. And I just listed a few of them here. First, there's me. Come see me in office hours. Now, I know I scared you. Like, I'm going to give you a 0. But if you come talk to me, I'll really help you. Because, you know, I want you guys to learn. I want you guys to be good students so I can brag about you. So if you come, I'll help you. 2, the website is actually going to be an important resource because every time I give a quiz, I'm going to upload the quiz there with the answers. Every time I give a test, I'm going to upload the test with solutions. I'm going to post reviews for tests. I'm going to post links to homework, links to whatever, like links to resources and all sorts of stuff there. So the website itself is a very important resource to help you do better. Free tutoring is available in the Marshak building, 4th floor. You can't see the Marshak building from here. It's on the other side. All right, so the Marshak building is the big, ugly science building. Okay. Lots of online resources like Wolfram Alpha. Even today, I use that all the time. Symbol Lab. Kids like that these days. Like it's more. It's kind of like a Wolfram Alpha, but it's more like templates. You can click it. If you know how to type math a little better, and you put in parentheses where you know the computer will know what you're talking about, Wolfram Alpha is probably better. Math forums you can go on, Math Stack Exchange. If you want to graph things, graph.dk or decimals.com. You're right, there are YouTube, Khan Academy, lots of stuff that I listed here, but there's help on the internet all over the place. A Google search can do wonders. Don't forget your classmates. You probably should actually get the contact information of one other person. You're in this together, help each other out. We have a Students Disability Services office. It's on the 1st floor of this building. If you think you have a disability that might affect your performance in the class, you should go talk to them. And you should do it soon, within the 1st week. That website, you can find more information as to whether or not you think what your struggles qualify as a disability. Usual class rules: don't eat in class, don't be on your cell phones, all that stuff. Work hard, be honest, don't cheat, that kind of stuff. More academic integrity stuff, don't cheat, I'll give you 0. Ending with the usual words of advice. The first piece of advice, and I'll give you much advice throughout the semester, but believe in yourself. That sounds very cheesy, but it's actually really important. Believe in your ability to actually learn and get better. Right? If you fail a quiz or you're just not getting something, I can't do this, I suck. No, don't do that. Just work a little harder, find out what you can do differently, figure it out, come to me for advice, and you try something else. I promise you, all of you here can do well. If you don't do well, it's a matter of poor planning. It's not a matter of poor intelligence. So do that. Yeah, just don't slack off. And also, which I have to say more and more these days, don't get emotional about things. So there are times when I would have students who do very poorly, right? get like in the teens on a test, and they'd look at me and they'd be like, I really understand what's going on, Professor. I don't know. It's just the questions were worded weirdly. If you got a 13% on something, you don't understand. Emotionally, you might feel like you do, but you don't, objectively speaking. You do not want to get lost in your emotions and feel like, well, I'm an A math student, so if I get a bad grade, it's Jhevon's fault. Well, no. You got a bad grade because you got it wrong, right? And it's a little bit harsh to say that, but it's the truth. So, just be assured that you're assessing yourself correctly. Assess yourself by the numbers. Don't study till you feel like you're doing okay. Study until you can get a bunch of problems in a row correctly. Get bored while doing it. Every time you look in the answer in the back, it's the right answer, right? Don't just be like, you do it, you got it wrong. Oh, well, I saw I made a little mistake, but I totally got it. No, if you got it wrong, you don't got it, okay? Go by the numbers, not by your feeling. Don't go, I feel like I'm okay. No, not good enough, especially in this class. Like I said, the class is much harder now. You don't want to actually mess up on that. Okay, some important dates throughout the semester, just a few things here from the academic calendar. The full academic calendar is at this link. You should actually read through it, see if anything's relevant to you. But I put a few things relevant here, like whenever the colleges close, like February 12th, no school, don't show up. On Tuesday, April 7th, it's a Wednesday schedule, so while we normally have class on Tuesday, Thursday, not that Tuesday, Thursday, so don't show up here, pay attention to the spring break camp, right? Final exam week, do not travel during the final exam week. You should only miss a final for emergency's sake. And if you have to make up a final, that's something you have to register with the math department to do. They're going to verify your sources that you actually legitimately missed the final, and you won't get a chance to make up the final until a few days before the exam, a few days before the next semester, right? So there are people who have to do makeup finals. That happened like last week, Thursday or Friday or something like that, right? So they didn't even know if they were going to pass Cal 1 to make it into this class because they had to make up the final so late. So don't miss the final unless you really, really have to. Yeah, last page, list of topics. This is what we'll be doing. These are suggested problems from the homework for extra practice. The problems in bold, I believe, are the problems where in the online homework there are similar problems to those. But the problems not in bold would be good if you know how to do them, even though they're technically not in your homework. Speaking of the tests, as I mentioned earlier, test 1 and test 2, their locations show up here. You'll notice for test 1, section RS2, your first test is Thursday, March 26th. The date is set in stone. Now, hopefully by that date I'll cover everything here and that'll all be on the test. But even if I don't cover everything, if I miss 1 or 2 topics, it doesn't matter. On that date, that's your first test. Whatever I cover up until that date, that's what I'm testing on. So Thursday, March 26th is the first test. We'll cover whatever I cover from up here. The second test is on Thursday, May 14th. That's going to cover everything the first test didn't cover. So the tests aren't cumulative unless it's incidental. So test 1 tests you on a bunch of things. Test 2 will test you on the rest of the stuff. Then there's the final. Again, I don't know the date, but that's a link to the final exam schedule. So once the final exam schedule gets updated, you'll be able to click on that and see when the final is. Okay, last page is that questionnaire that I asked you guys to fill out. Just attach it. And we're going to hand it in to you. So I'll give you guys a couple minutes to finish up on that. In the meantime, are there any questions? Yes.
Are the grades only gonna be on that paper?
Yes.
It's not gonna be a blackboard at all?
Yeah, I don't think that's
Just out of curiosity, what is the not done in class? I'm assuming those are not covered.
Oh, yeah.
Yeah.
Exactly. So if you look at the topics, you will notice that in some sections, it says like not done in class, not done in class, not done in class. When it says that, what that means is it's really stuff that you did in Calc 1 that I don't want to waste time going over because the syllabus is harder. Like the hours I would have spent, the 2 or 3 hours I would spend going over that stuff, I'd rather use it somewhere else to do 3D stuff or something else. So these are things that technically it's in our syllabus, but also technically you did it in the last 2 weeks of Calc 1. I'm not going to go over it. If you ever need to review any of these things, like I said, you have a link to my class videos. So you can actually go over all that stuff. As well as, oh, that's something else I forgot. Homework is already posted, so you should get the access to the homework pretty soon. Okay, so homework already out. I believe they're due February 7th, so next week Friday. The homework will include problems on the review sessions. So there's a homework that's going to test, do you remember how to integrate something? Do you remember how to find a definite integral, an indefinite integral? Do you remember how to deal with logarithms and exponentials? Yes?
Was the course code for the Pearson on my lab?
Oh, it's on the website.
It's on the website?
Yeah, so if you go to my website, there's a section labeled homework. All the instructions are there, and there's a link to a PDF that shows the course code. So everything you'll need to get signed up for the homework is on the website, which is here. So go there and you can get it. You can also go to the main math department website or just Google Math CCNY, find the main site, click on people in the left menu bar, click on my name, it'll take you to my page, and you click on your class and it'll take you here. Yeah. Other questions? Yes?
Okay. So what's the difference between like the website with your name and like the website up here?
The difference between...
Like the website with your name?
Yeah, so this website here is my main website page. So all the classes that I taught, they all have pages there.
Okay.
So you'll like see, oh, the classes Jhevon taught in fall 2019, the classes he taught in spring 2019, blah, blah, blah. But if you want to click on your specific class, for this class, it's the top one.
Okay, thank you.
If you go here to my main page, you'll also see a link, spring 2020 classes, and then you'd have to click on section RS2.
Okay.
Yeah, other questions?
For the homework, like how many days you're giving like us to do the homework?
So the first sets of homework is due February 7th. That would cover 5.5, 5.6, 7.1. Okay. And in general, maybe a week, a little less. So usually every time I finish a topic in class, the homework for that is going to be due by the following week or latest. I can't leave it too long. You guys really have to keep up. Other questions? Yeah.
So the lectures that you record is going to be put up after?
I'll post them on YouTube, and you'll be able to find a link to the playlist on the class website. Other questions? So, since we don't want to waste too much time, I actually want to talk about a few of these things. So 7.1, I don't want to do it, but I will mention some highlights and some differences. Which talks about the logarithm as an integral. So basically what this goes through is it gives you a definition. That's my short definition. And it says, okay, we're going to define the function ln x by an integral. We're going to think of it as the integral from 1 up to x of 1 over t dt. So they define the logarithm as giving you the area under the graph 1 over t between the interval 1. So the area from 1 up to x, they define that area to be what the logarithm is. Right? Then they can derive from that, well, if we were to differentiate this, the derivative of ln is going to be the derivative of 1 over t dt between 1 and x, which, by the fundamental theorem of calculus, part 1, will actually tell you that that gives you 1 over x, but we all knew that, which is kind of the point. They give you an alternative definition, but then they derive everything else that you already knew. So everything that you learned in Calc 1 about exponentials and logarithms, they just rederive all that stuff in 7.1, just from a different perspective, from the perspective of thinking of the logarithm as an integral. Now, in my opinion, it's not a very helpful definition for a Calc 1 student or a Calc 2 student. It's just, there are cases where thinking of a logarithm in this way is beneficial, but really that'll show up in complex analysis, maybe Calc 3, maybe some other higher classes. But in a Calc 1 or Calc 2, I don't really see a reason why a student would need to know that I can define the logarithm in this way specifically. So I much prefer the way I define exponentials and logarithms in Calc 1. So in lecture 2, if you go to my Calc 1 playlist, I talk about exponentials and logarithms, and I build them from the ground up. And I use them to derive the power rule and all the derivative rules, like we build everything up. And this section pretty much goes over that. And then it defines E is the number, so that the area under the curve is 1. Integrate from 1 up to E of 1 over t dt, you get 1. Which tells you that the log of E is 1. You can also get from this definition that the log of 1 is 0, but again, you would know all that stuff. So you never really get anything really new. You just get a different way to look at a logarithm, which can be beneficial, but not really in a Calc 1, Calc 2 context. I can't really think of a situation where, Calc 2, knowing that, you couldn't do the problem unless you knew that. Like, I can't think of such a situation. So I kind of feel like this section is pointless to cover right now. Just, they give you another definition, and I don't think it's useful for us. But other than that, they just derive all the other stuff. They derive that the derivative of e to the x is e to the x. They derive a bunch of stuff from this definition that you already know, and I don't think it's worth the time. Anybody got time for that? Okay, so this is the new definition, and they derive everything that you already know about exponentials and logarithms from that definition. And as such, we're gonna skip it. It's not worth the time. We need the real estate. In 7.3? Yes, so 7.2 is skipped, it's not in our syllabus, but 7.3 talks about hyperbolic functions. Now, some of you may have seen this before, some of you might not have. I'm going to run through it very quickly, just give you an information dump. At this point, it's not really something to understand, it's just something to just know about and be aware of. They are useful, again, in complex analysis and higher calculus classes. And even in Calc 1 and Calc 2, these guys will be useful, but at the same time, you could get away with never using them. Like if you forget these, like next week I'm going to quiz you on this because I actually did it in class. But if after that you never use them in your life, you'll be okay. Like you'll be all right. There are situations where you might have a minor inconvenience, but it's not something that's worth, oh, I need to learn this whole new set of topics to actually do. But they're nice things, they're interesting. So let's just quickly actually talk about them. So the main functions in this section are y equals cosh x, so it's pronounced cosh of x, and y equals sinh x. So these are kind of like trig functions, but they're not. Sometimes they're called hyperbolic trig functions. So this is pronounced sinh. So you have cosh x and sinh x. This is the hyperbolic cosine. And this is called the hyperbolic sine. Now, if you go far in math, if you're a math major, you're going to see the word hyperbolic. It's kind of like a hyperbole. It's very funny that the word hyperbolic can mean all sorts of things. Like they'll throw out the words hyperbolic for all sorts of stuff. But here, the word actually makes sense because it actually comes from a hyperbola. So these are analogous to your good old-fashioned trig functions, cosine x and sine x. They're very similar, except where cosine and sine deals with a circle, these guys deal with a hyperbola. So remember what cosine and sine did. If you had the unit circle, did all this in pre-calc if you want to go back and remind yourself about trig functions. Cosine and sine gave you the coordinates on the unit circle. The x-coordinate was given by cosine of theta, the y-coordinate was given by the sine of theta, if the line connecting the origin and that point measured an angle theta with the positive x-axis. You kind of have the same idea with these functions. If you look at cos x and sinh x, they look at the unit hyperbola, and they kind of do the same thing. So this guy has equation x squared plus y squared equals 1. A hyperbola has equation x squared minus y squared equals 1. And the graph looks like that. Extend like that. And if you sort of measure a line from the origin to a point on this curve at an angle theta, the coordinates of that point is given by cos of theta and sinh of theta. Just as with trig functions, we may or may not put the parentheses on the function. It's kind of understood. If it's right beside it, it just means it's plugged in inside the function. But that's kind of where they come from. So in the unit circle, we can think of the x-coordinate and the y-coordinate as separate functions. We'll talk about a topic called parametric equations soon, where we'll realize why doing something like that is actually super useful and super convenient. Thinking of functions that measure the x and y coordinates separately, as opposed to just one equation that measures them simultaneously. So you can do the same thing with a hyperbola, and that's how you come up with these functions, the hyperbolic sine and cosine. And sometimes they're called hyperbolic trig functions, though not always, because they actually function, pardon the pun, a lot like trig functions. So a lot of the identities, these guys will have similar identities that go with them. A lot of the rules of calculus here, you'll have very similar rules with these guys over here, and you have very similar things defined. So for example, cos squared minus sinh squared would give you 1 instead of adding them. So you know cosine squared plus sine squared equals 1. With hyperbolic trig functions, it's a minus sign instead. And again, because it's modeling x squared minus y squared, not x squared plus y squared. And by definition. And it turns out we can derive, I'm not going to do it because it's kind of annoying, but we can derive the fact that the cosine of x, cos of x, you can actually write it as an exponential function. It's going to be that guy. And the sinh of x, you can also write it as an exponential function. It's actually that guy. You're going to know these guys, know what they're measuring. They're measuring coordinates on the unit hyperbola. And this is how you can actually write down a formula for them. So you can't really write down a nice formula for cosine unless you're doing a series. But for cos and sinh, you actually have nice formulas for them in terms of exponentials. So that's pretty nice. You can also define the other hyperbolic trig functions. So we can define what's called the tanh. And so that's pronounced tanh. And just like you would expect, it's sinh over cos. You can define the hyperbolic secant. That doesn't really have a nice short name. That's 1 over cos. You can define the hyperbolic cosecant, 1 over sinh. You can define the hyperbolic cotangent. I don't know if they call that cotangent. People don't use that very often. This is 1 over tanh. Yeah, question?
Calling Kotesh.
Kotesh. So you can make those definitions, and since cos squared minus sinh squared is 1, you can divide both sides by cos squared, and you would get 1 minus tanh squared equals hyperbolic secant squared. Which should remind you of another trig identity, 1 plus tangent squared equals secant squared. 1 minus tan squared equals secant squared. So here are some things you're going to notice with the hyperbolic trig functions. They'll have a lot of formulas that look almost like the trig function formulas. The difference is, sometimes where a trig formula would have a plus sign, they'll have a minus sign. And sometimes that will actually come in handy. Right? I'll mention some situations where that will come in handy. So there'll be a lot of situations where you'd be in a case where I want to use trig functions here, but the sign is off. Sometimes a hyperbolic trig function can actually do what you want it to do with the trig function in that scenario. So you'll always have workarounds, but it's a nice quick thing. So sometimes you have forms where it's almost like a trig function, but there's just a sign that's off. One little detail that's off, and in that case you can use the hyperbolic trig function instead. By the way, for the uninitiated, every time I write something in a box, that means that's something I expect you to know, right? So usually, if I give you a definition or a formula and I put it in a box, it means that next week on the quiz, in problem 1, chances are I'm going to ask you about that formula. Hey, what's the formula for Koch? Right? I expect you to be able to write this down, right? So boxing things is what I expect you to remember. So you can have things like that. So that's something that's nice. They work a lot like trig functions, but they might have a sign off here or a sign off there. Which, when it comes to memorizing the formulas, might be a minor annoyance, but that's actually what makes them useful also. The fact that they're almost like trig functions, but you can get away with different signs that you would want to have in terms of the graphs. Your Koch looks like, well, to the untrained eye, it'll look like a problem, but it's not a problem because it's actually asymptotic. So this isn't a part of the graph. I'm just showing you what there's an asymptote. It's actually asymptotic to e to the x over 2, and this graph here, these pass through the origin. This will be e to the minus x over 2, right? So this looks like a parabola, but it's not. It's actually increasing at the speed of e to the x over 2, which, something else I expect you guys to know, exponentials increase a lot faster than polynomials. Yes?
Is that e to the x quantity over 2 or e to the power of x over 2? How much?
Well,
what's
no,
over
e
2?
to the x over 2 would be written like that.
So is it, okay. I just didn't know how big the over 2 was.
Yeah.
Okay, I got you.
Right, it's like you're adding the e to the x over 2 plus the e to the minus x over 2. And yeah, so that's what that graph will look like. So yes, I expect you to know that exponentials increase a lot faster than polynomials. Logarithms increase a lot slower than polynomials. Things like that you should know, especially how that applies to limits. If you look at the sinh, again, that's something that might look like a polynomial at first. It might look like x cubed. But it's actually not x cubed because that is also, that's e to the x over 2. So that also increases like an exponential. And below that, this guy is asymptotic to minus e to the minus x over 2. Right? So it it looks like an x cubed, but it actually increases at the rate of x e to the x over 2. So those are what the graphs look like. So you probably never would need them. One thing that's important from the graphs is when you're looking at inverse functions. So for the sinh, the inverse function has domain and range all real numbers because that is 1 to 1 and onto. For the cosh, that's not the case because it's not 1 to 1. So if I want to find the inverse of the cosh, usually we cut off the left side and we just find the inverse of the right side. So the cosh inverse graph actually looks like that. Almost like a logarithm, but it doesn't extend down. It starts here and goes off. Inverse hyperbolics are also pretty useful sometimes. What else do I want to tell you about these guys? Let's do some calculus. Like I said, these are just definitions to know, not so much to understand what's going on, but just to know, be aware of it. Calculus. Now let's talk about derivatives. We know the fundamental theorem of calculus now, so we also know every time I give you a derivative rule, it's an integral rule in reverse. So I don't have to talk about integration, I'm just going to talk about derivatives. Let's say you wanted to differentiate cosh. Well, that means you'd want to differentiate e to the x plus e to the minus x over 2. Now we all know when you want to differentiate a fraction where the denominator is a constant, you can leave the denominator alone and differentiate the numerator. Derivative of e to the x is e to the x, derivative of e to the minus x is minus e to the minus x. Okay, what's that? That's sinh. So the derivative of cosh is sinh. In fact, similarly, by just writing things in their exponential form, you can derive a bunch of formulas. Like the derivative of sinh is cosh. So as I mentioned, the derivative of cosh is sinh. The derivative of tanh is hyperbolic secant squared. So again, very similar to trig functions. Where they start to take a turn is when you look at the inverses, so the reciprocals, I should say. The derivative of hyperbolic secant, what's the derivative of secant x, the regular trig function? Secant x times tangent x, but the derivative of hyperbolic secant has a negative sign on it with the hyperbolic secant and tangent. The derivative of the hyperbolic cosecant also has a negative sign. That's hyperbolic cosecant, hyperbolic cotangent. The derivative of hyperbolic cotangent is minus hyperbolic cosecant squared. For these, I'd probably expect you to remember these. So you can do that. Those are derivative rules. And of course, you can integrate the right side to get the left side, plus c, by the fundamental theorem of calculus. What else do we know? We can talk about calculus with the inverses. So let's say I wanted to differentiate the inverse function of cosh. What I could do? I'm going to derive it similar to how we derived. Maybe I should ask you guys about that. What's the derivative of tan inverse? What's the derivative of sine inverse? So in terms of inverse trig functions, I expect you to know those two derivatives. I don't care about the others. But when I derive these in Calc 1, I use a similar method to what I'm going to do here. You set y equals, of course, cosh inverse, which means cosh of y equals x. You differentiate both sides implicitly. The derivative of cosh y will be y prime sinh y, because derivative of cosh is sinh. Derivative of x is 1. So your y prime, the derivative of what I want, is 1 over sinh. Now you remember, of course you remember, because you just did it. Cos squared minus sinh squared is 1, which means that your sinh is going to be the square root of cosh squared minus 1. You ignore the negative, like I said, because for cosh, for the inverse, you actually ignore the negative side. So it's not plus or minus radical, it's just a radical, positive radical. So you just take the positive radical, so I can take that and swap it in here. And what you're going to have is y prime is 1 over the radical of cos squared minus 1. And cos squared y. That's a y. But what is cosh of y? Cosh of y is actually x. So this is 1 over the radical of x squared minus 1. In other words, if you differentiate cosh inverse, it's 1 over the radical of x squared minus 1. You'll notice that's very close to the derivative of sine inverse. The difference is, the guys is turned around. So if you're in a situation where you have the 1 over the radical of 1 minus x squared, oh, that's a sine inverse, right? But if you see 1 over radical of x squared minus 1, like it's not the sine inverse, it's something else. It's actually a cosh inverse, right? Now, you can deal with this in other ways other than thinking of it as cosh inverse, but sometimes it's convenient to just say, oh, that's the derivative of cosh inverse. So it's kind of like, it's almost like a trig function, but it's different enough to be used in a similar situation where the signs are just slightly off. Using all those formulas, similarly, you can know that the derivative of the sinh inverse is actually 1 over the radical of x squared plus 1. So if you want to integrate this, you can say it's actually sinh inverse plus c. There are going to be other ways to integrate that, which we'll talk about in a couple weeks from now. Knowing the inverse tangent is also useful, 1 over 1 minus x squared. So at this point, you guys know that the integral of 1 over 1 plus x squared is actually tangent inverse. If you were to see the integral of 1 over 1 minus x squared, you can actually think of that as tangent inverse. Again, this is something that we're going to find another way to integrate it, which is, it's not that bad, but if you just knew this formula directly, that's even nicer. You don't have to know it, but it might be convenient sometimes to just, oh, that's the answer of that integral. We're going to do this using partial fractions. And don't know what that is yet, don't worry about it. Let's see. Do I want to tell you anything else? So, yes, kind of it. Those highlights. Just some nice formulas to know. Which every now and then you'll come up with situations where, again, the hyperbolic functions might be very convenient. You see that integral, it's convenient to just know, oh, that's tangent inverse. But again, there are going to be other ways to look at that thing. Everything you use a hyperbolic function to do, we'll look at another way that you could have done it, so you can actually survive without. It's a nice thing to know, and it's in our syllabus, so I have to kind of talk about it. I'm not writing the final, so if they throw in one of these guys on the final, like I wouldn't put this on the final, but I'm not writing the finals. Just, I should mention it. do some examples just to get you, they're not meant to be hard, but just to make you get used to using the rules. And of course, check that you remember the product rule, the quotient rule, all that good stuff. Check that you remember how to differentiate a logarithm. What's the derivative of ln? d dx of ln u. U prime over u. d dx of e to the u. U prime e to the u. Okay, so things like that. D dx of 5 to the sinh x. What's the derivative of, if you have a to the x, a is a constant, a greater than 0 constant. What's the derivative? A to the x, ln a. Expect you to know that. E. d dx of tanh x over x. F. Find the integral of tanh. It'll actually have a very similar formula to the integral of the regular tangent. G. Find the integral of e to the 2x over 1 minus e to the 4x. Now, as of Calc 1, that integral would not be an integral you can do, but based on what I told you today, you can now do that integral. You can use hyperbolic functions to do that integral. So just try those. We'll pick up next class with doing these. So try those for Thursday and start working on the homework. Whew, that was odd. But that's kind of all I want to do for that section. I want to actually start fresh on Thursday with continuing integration techniques. So on Thursday, we're going to jump straight into integration by parts, 8.2. We'll start the class by going through these, but actually try them on your own at home. I'm sure that you've done. Any questions before we move on? It's a weird shaped room. Oh, I don't know if you guys can see from that angle. Yes.
So are we having like equivalent what we just went through?
Yeah. So
tomorrow?
next week next week I'm going to quiz you on what we did today and on Thursday. So you're
So is it
going
gonna be like just once a week, not twice a week?
Yeah, once a week.
Okay.
Once a week. That's okay. Usually every week. Other questions?
Yeah, for exams, the first year, you said that the department's not writing them, you're writing them?
I'm writing the in-class exams, correct. So the department is writing the final. I'm grading, but I'm not writing. So, I won't know what they'll throw on me. Did you have a question? Anyone else? I think I saw 2 hands. So you can have fun with those, and hopefully you have those questionnaires filled out. I will check to make sure these people are on my roster. Anything else? And everyone got 2 handouts, right? So one is the syllabus, which I read through. The other is the course learning outcomes. So we have to have these because we're accredited, and they should let you know technically what you're supposed to be doing in terms of learning outcomes. So with that, we can move into the next phase, which is our first quiz of the semester. Oh my God, I'm so excited! Okay, so you can put away your stuff, and we will begin. It's not on this stuff, it's on calculus. So you're all that way. It's pretty easy. It's like Calc 1 stuff, last semester. And Once you're done, you can leave and you can hand in your quiz as well as the questionnaire. Pass it around, pass it around.
Normally, I get
Yes.
extra time, like, you know, in the accessibility office.
Yeah, as I said, you should go talk to them.
So I didn't really get a chance. This is our first day, like this first quiz.
Yes, you have the first week you should talk.
What?
So see them later in the week.
So like basically, I can't believe like we have our first quiz. Like, you know, what's going on here?
Do your best.